Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at maps in the standard template library in C++. So after vectors, maps are probably the next most useful collection, really worth knowing about. They're a little bit more complicated because, as we'll see, we're storing a bit more information in there. So let's include map in there, and we'll have using namespace standard. A map allows you to store key value pairs. So it's like a lookup table. The idea is that you can store bits of information which you can retrieve with a key. So we'll take a look at an example of that. Let's try, for example, let's have a map that has a string for the key and an int for the name. So this could be, let's say, the string could be a bunch of names of people, and the int could be the ages of those people. So I'll call this, let's call it ages. So to add items to this map, we can use an overloaded array subscript operator, which looks like this. So we can say ages, let's give this a name. Let's say Mike equals 40. So we've stored the value 40 using this Mike name as a key. I'll add a couple more examples into this map. Excuse me. So let's add Raj. Let's make Raj 20, and I'm going to add Vicky, and Vicky can be 30. Now we've stored those in the map, we can retrieve them in basically the same way. So let's do cout, and for example, ages, use the array subscript type operator to access the values, and let's get the age of Raj out there and output that. So if I run this, then we get 20. So just using this basic idea that this is just what you do most of the time with a map, and as you can see, it's really actually quite simple once you get the idea. It's literally just like a table where this is kind of like the first value in a table, and you can use that first value to look up the second value. You can also, of course, iterate through maps, and it's a little bit more complicated, but not much, just because we've got key value pairs in there. So let's use a for loop, and we're going to do something really similar to what we've done with vector and list. So we can say here for map string int, and we need an iterator of the right type here. So iterator, let's call it it and set it equal, just like with vector, let's set it equal to ages.begin. And we're going to keep going as long as the iterator does not reach ages.end, which is an iterator that's off the edge of the map, so to speak. And then let's just increment the iterator with this overloaded postfix ++ increment operator. So now, to access the elements in there, we don't want to use the iterator directly. We can use it arrow first, so it's as if it's a pointer to an object, or let's say a struct, which has fields first and second, and those are the keys and the values respectively. Let's output some punctuation, and also output second in here, and then finally we'll have an endler. So if we run this now, then we've output all the keys and values in the map. Now the key is unique in a basic map like this. All the keys are unique. So if I, for example, said ages, let's say ages, let's put the operator in there, and let's try to add Mike again, and this time I'll make him 70. If we now run this again, we see that Mike in the map now has value 70. So because we tried to add a value with the same key, we've literally overwritten the original value. So this kind of makes maps useful for storing, for sorting out which of these are unique because the keys in the map are always unique. Another very common thing to do with a map is you want to test if a value is in a map. And you might think you could do it like this. So let's say cout, let's say, in fact, yeah, let's use this. Yeah, I'll define another line here, but actually I'll just copy this one because it's the easiest thing to do. So we've seen that if I try to access an element that's in the map already, then that works perfectly well. We can see that here. What if I try to access an element that's not in the map? Let's put Sue in here, which is not in the map, and run this. And we find that we've got naught in there, so it's as though we've added Sue with age naught. And if we then look at the list, Sue is actually in there with age naught. So simply using these array subscript overloaded operators, simply trying to access that value has added it to the map, which is not what we usually want. So if you want to test if a value is in a map, the way to do it is like this. Let's say if ages, and we're going to use the find method, and we're going to see if, let's see if Vicky is in there. Now this returns an iterator, which is either going to point at the right element, or if it's not found, it's going to point off the end of the map. So let's say if Vicky is not equal to map.end, then we can do cout found Vicky endler. Else, let's say cout key not found endler. So let's just run this and check that it actually does work. Oh, sorry, not map.end, of course, ages.end. We need the specific map that we've created. We need to get the end iterator from that. So if we run this, we see that it says it's found Vicky, and it hasn't added Vicky to the map, which is what we wanted. If we change this a bit, for example, by adding a 1 on the end of it or something, so this key is now not in the map. And if we run this, it says that key is not found. So that's the right way to check if a value's in a map or not. You might wonder what's actually stored in the map. So what is this iterator actually referring to? And it's actually referring to what we actually store in the map is actually of type per, which is another template class. So what we could do is another way of iterating through this map, another way of getting the values out of it. Let's maybe take a copy of this loop. Would be like this. We could say per, and it's got to be a pair of the right type. So string int. Let's just call it. Let's call it maybe age equals the thing pointed to by iterator, and it's this per that has elements called first and second. It has instance variables first and second, which are publicly accessible. So now we could do we could do the same as this. So maybe let's copy this. But instead of using it.first, we can say age.first. That's going to be the name. It's going to be the key in the map, and age.second, and that works just as well as before. This means that another way of inserting values into the map would be we can actually create a per and then add it to the map. So we could say up here per string comma int. Let's call it add to map equals. We'll use the constructor and we'll add in there something like Peter, who's extremely old. Let's say he's 100 years old, and then we could say. So I've declared a pair, and I've just called it add to map, and then we could say ages.insert add to map like this. So we can insert that pair into the map, and if we do that, it works exactly as before. So sometimes you see that syntax in there using a pair. Of course, we don't have to go to the trouble of even declaring a separate variable here. What we could do is just use the pair constructor directly and put Peter 100 in there, and then we can delete this line, and that's also going to work just the same. Now, because it's a bit of a kind of mouthful in programming terms to have to declare this pair with its types, there's a handy kind of I guess it's a function that you can use called make_pair, and that returns a pair of the right type. So we can say make pair and Peter 100, and if we run this, we find that this also works. So I think that's basically it for this tutorial. There's more to be said about maps. In particular, something that you're often going to want to do is use an object of your own class that you've defined as the values in your map. It's less common to want to use your own custom class as the key in a map, because if you think about that, it just doesn't arise very often. It's not very often you'd want to do that. It's more likely that you'd want to kind of build up a sort of library of your own of objects of your own class type, keyed on some integer or string or something. And you can do both of those things. You can use your own objects of a class you defined as the key or the value in a map, but you have to do a little bit of extra work on your class to get that to work. So we'll take a look at that possibly in the next tutorial, or certainly a future tutorial. So I think we'll leave it there for this tutorial. To practice this, of course, just typing out this code is one really good thing to do. Another thing you can do is use just cout and cin to create a simple menu system that allows you to enter, let's say, strings and another piece of information as well, which could be another string or a double or an int or something, and then stores them in a map. And that will mean that you can provide a menu option that allows you to search the map for a particular string. So it's like you've got a little database application. You don't have to implement saving necessarily, but you can have a little database application that allows you to enter pairs of values and also allows you to search for values in that database. You could do that using a map. And of course, another possibility, which we'll take a bit of a look at later on, is that you could build up a complex data type, like, for example, a map of vectors or even a map of maps, something like that. One little note of caution is that maps, it's easy to overuse maps. Sometimes it's better in situations where you might think you need a map. Sometimes it's better, for example, to have a vector of objects of your own class type. So the class could store a bunch of bits of information like age, name, height, whatever you like, and you could store those objects in a vector rather than building up a load of nested maps or something. So it's easy to overuse maps, but of course there are some situations really where you really want to use them. So that's it for this tutorial. Until next time, happy coding.